Welcome to the new Microjam. This one focuses on drag and drop capabilities for 2D game effects. The drag and drop essentially refers to any time that you can touch on some object, move it around, and then drop it again, like this. Notice that I'm dragging the water can around, and when it's hovering over the plant, it'll be tipped down, watering the plant. The sun here does a similar thing, and notice that the health gauge is going back up under the plant. Lastly, the soil bag will do the same thing. Once you get the plant's health back up, the plant will come back to life. Now, making a game like this might have been a little difficult to start, but with these subgraphs that I've provided and this lesson that you're about to see, it'll become so easy that anyone will be able to create a game like this. Today I'm going to focus on 3 main subgraphs, and then we'll dive into a few bonus things. We've got the touch, drag, and drop subgraph, which is the real meat of this project. By just adding a scene object into this object picker, as you can see the watering can is in this one, you'll be able to drag and drop that watering can all over the place. In order to illustrate the problems that this subgraph is solving, I'll show you a demonstration of a subgraph setup in the same way that a lot of games that I've seen are set up. First of all, snap to center is set on all of these objects, and the global tracking of whether or not an object is currently being grabbed is going to just default to true. So it always thinks that no object is being grabbed. If we go ahead and we just try to grab one of these, you'll notice they'll all become grabbed and they'll all snap to the center of the touch immediately. This makes it impossible to use any of these objects alone, and they're all stuck together for the rest of the game. This is pretty much the worst case scenario, but we can fix it with a couple different things. If you notice, we can unclick snap to center, and this would at least allow us to pick them apart and they wouldn't get stuck on each other as easily. You would still drag them together, but you could still probably pick them apart. The other way is to just plug in a global Boolean variable. This one's just called isTouchEmpty, and notice that it's the same one in all of them, so they can tell if any one of the other objects is being grabbed. Now, you'll only grab one at a time, and this makes it a little easier to pull them apart, and it solves a lot of problems. Now you can have very precise 2D games that don't act all buggy in the wrong situations. Notice that the events coming out of it are start, stay, and stop. So you'll be able to control other parts of your game based on if this specific object is being dragged, if it got picked up, or if it's dropped. So those are separate events that you could really program anything to, and I'll show you what we did in a moment in this project. You also have the position of the dragged object, which is really useful, especially when it doesn't snap to center. It's going to be different than your touch position. Let's see where our output events go. So right off the bat, you can see when we're dragging our objects, they're going to check constantly if it's hovering over our hover zone. Our subgraph here on hover will let you add your object, your hover object, which is the watering can, and then a hover zone. If you take a look in the hierarchy, you'll see the interaction hover zone that I've created. And if we just turn that on, you can see it's just a green square. This is just a visualization to help us see where this hover zone is. You don't actually even need the image, and you can actually delete it altogether. You just need the screen transform with the size here. And it uses that screen transform, as you can see in this object picker, the little green squares, to just figure out where on the screen this object is. So then when it sees that the hover object is overlapping with the hover zone, then it'll output its own events for when you start hovering over, and then for when you hover over the hover zone every frame. And then also, as soon as you stop hovering over that, we'll have this stop. So that means that when we have our watering can animation that has a start and a stop, we can tell it to start when we start hovering over that zone, and then stop when we either stop hovering over the zone, or you might also notice that the drop from the other subgraph is also linked into the watering can animation stop. So it'll stop animating as soon as we let go. In addition to this drop signal, you might notice that we placed it into this sequence node so that we can split the signal so that it stops the watering can animation and then it does something else. So let's take a look at what else it does. We can see it's going to this snap to point subgraph. This is the third subgraph that we want to talk about in this video. And this subgraph just handles what happens when you drop the object. You don't need this in all of your projects. This is only for when you have an object that has a place it needs to go. That could be a shelf on the side of the screen, like in this example. When I let go, the move to point will be triggered and it will move back to this snap point. Now you can see at the start of the effect, we trigger set snap point and we set it to wherever the watering can is. So if we did have the watering can sitting somewhere else on the screen at the start of the effect, then it'll snap back to that point. Now you can set this snap point at any time you want. So you could pair it with some other subgraphs that we've added to the asset library that help you find the closest point to your object in a list of points. The puzzle pieces that I mentioned before could have specific places that they could slide into, and maybe whichever one you're closest to, it will drop into that spot. Something like that. And then we could change the speed that it snaps back by changing this transition speed value. Now this is somewhere between a duration and a speed. This is the amount of time that it would take one object to travel from one corner of the screen to the other. And then it'll keep that same speed no matter how far away you're dropping it. This prevents it from being a specific duration where it moves very slow when you drop it right next to its starting point. And it just always basically will look good. So just mess with this value until it works how you want it. And then if you do need events, there's also events for when the transition starts, stays, and stops. For instance, if you need something to happen when the object gets back into its correct place, then you can use all of those events. If you look through here, we've basically repeated the same subgraphs and the same format for each of these items. The only difference is they each have their own individual animation subgraphs that are super specific for this project. Let's take a deeper look at the touch drag and drop subgraph, since that's the most important piece here. If we take a look at it, we notice that there's a grab section, a drag section, and a drop section, which makes it very straightforward to understand what's happening. And as you can see, this finger touch 1 point node is the main thing powering this drag and drop. It has an on start, stay, and on stop, and then it has the position of the touch. Now, as a bonus that we've done for this microjam, we've created a second example project showing how you don't really need touch to be the only interaction. You can create subgraphs that are event-based like this, where there's a start, stay, and stop, and you can use that with any sort of interaction that the user can have. For instance, a byte drag and drop subgraph. Let's take a look. In this project, we just have some fruits and some baskets that the fruits need to go into. So how can we move these fruits into the proper baskets? Well, one way might be to just directly drag it ourselves with the pinch drag and drop subgraph. We also have the byte drag and drop, as well as the eye blink left and eye blink right. So these are all very helpful subgraphs, and all they are is the exact same touch drag and drop subgraph with new events. So we created these different events based on different facial interactions and hand gestures to show that instead of touch, you could easily create your own interactions with unique different things that keep the user's face on the screen. This is a mouth close event. We're literally just using the mouth open detection and reconfiguring it so that it matches the touch events, along with getting the face points for the mouth to get the center of the mouth, which is the position, and the mouth edge, which is almost at the side of the mouth, which could be used to determine the radius of the mouth in case you wanted to make the user's mouth eating a bunch of objects or something. So instead of touching the screen to interact with an object, you could just check if they're biting the screen in a certain position. And that could be super fun, super engaging, and just unique. Maybe you can think of your own events other than the hand pinch, the eye close, or the mouth close events. And I really hope that you found this demo fun, and I hope that you found the rest of the microjam fun, and I can't wait to see what everyone makes. So give us a shout out if you liked this microjam, and show us what you made.